Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with chemistry. The topic is spectroscopy, ultraviolet spectra. This is lecture number 15 in this series. Okay. In previous lecture I explained you what is bathochromic or red shift of UV spectra. Now I will explain you what is hypsochromic shift or blue shift of UV spectra. Okay. So normally, spectra of UV visible appear because of at least two alternate pi bonds in a system, and this is called Dine system or pi electron system. Okay, if we can engage pi electrons which show conjugation in some other kind of attraction, then they will not be easily available for electronic excitation. Okay, and therefore the energy required to excite electron would increase and wavelength decreases. This will lead to shifting of UV spectra, that is peak, towards blue color, that is lower wavelength, and it is known as hypsochromic shift or blue shift. The best example is aniline. Aniline has NH2 group on top of benzene. This NH2 group is oxochrome. And main function of oxochrome is to increase wavelength of a given substance. And therefore, if we compare lambda maxima of benzene and aniline, you will see that benzene is having lambda maxima 255 and aniline is having lambda maxima 280 nanometer. So this increasing wavelength is because of the presence of NH2 group on benzene. Why? Because lone pair of electron on nitrogen is available for extra conjugation, and this will lead to decrease the energy and increase wavelength, and that is why absorption of aniline would be at 280 nanometer. Now, if in acidic medium aniline is treated, because it is base, it will react with HCl. This lone pair will be utilized by H plus, and nitrogen will form fourth bond with hydrogen plus, and with the help of lone pair of electron. Therefore, now lone pair of electron is engaged in formation of bond with hydrogen. Okay, so it is not available for further or extra conjugation. Okay, so because of the presence of HCl or in acidic medium, lone pair of nitrogen is utilized for bond formation, and extra conjugation is removed. Therefore, lambda maxima will shift towards lower wavelength, and it is like benzene only. So the lambda maxima is about 250 nanometer, that is of benzene. So this way, this is the example of hypsochromic shift. So when we engage electrons in another kind of attraction, then there will be no conjugation or extra conjugation, and that will lead to the lower wavelength. Another example is solvent. So this may occur if polarity of the new solvent used is more than the old solvent, or it can occur by introducing polar groups also. Mainly oxochrome. For example, we take carbonyl compound where R can be different groups. So if R is equal to H, lambda maxima would be 293 nanometer. Epsilon maxima would be 11.8. That means it is having low intensity. And here solvent can be hexane, normal hexane. So this is about aldehyde, because when R is equal to H, it becomes acetaldehyde group. Now, if we use OH instead of H, we put OH over here. So OH is more polar, but lambda maxima is 204 nanometer. Epsilon maxima slightly increased, that is 41, and this solvent should be alcohol. Now what happened when we introduce OH group to this compound? So what happens, see this, CH3, C double bond O, oxygen as lone pair, and now here we have OH group also, in which there will be oxygen with lone pairs. So alcohol which is having polar group OH, where hydrogen is partly positive and this oxygen is negative, you will find hydrogen bonds. Similarly, here also formation of hydrogen bond takes place with solvent molecules, and that is why due to hydrogen bond, here these lone pairs are involved in bond formation. Okay, so in case of OH groups along with carbonyl group, OH group and of course C double bond O group will form hydrogen bonds with solvent molecules. That is alcohol. So thus hydrogen bond occupy non-bonding electron pairs, and make difficult N to pi star transition. And therefore lambda maxima decreases, which is called a blue shift or hypsochromic shift. So that's it in this lecture. Thank you so much.